In this video, we're going to see some different rules that will make finding derivatives much easier for us. We will not have to use the limit process anymore. We will just be able to use some of these basic rules to really simplify our work when it comes to finding derivatives. The first one is the constant rule. So the derivative of a constant is always 0. Now think about that for a second. If we have a constant, if we graph the line that is constant, then the slope at every point of that is 0. So the derivative of that would make sense to be 0. So the derivative of any constant is 0. The constant multiple rule. So let's say that we're taking the derivative of a constant times some function of x. So maybe something like 2x squared. The constant does not affect the derivative. So we can pull the constant out to the front and multiply that. Oops, that shouldn't be 2. That should be c in our general form here. It would be the constant times the derivative of whatever function of x we might have. So in our example down here, the derivative of 2x squared, we could pull the 2 out front, and then we just worry about taking the derivative of x squared. Compare that to limits. Remember we had limit properties where if we had a limit as x goes to something, and we had a constant times our function, we could pull that constant outside of our limit. And it's really the same rule because remember the definition of a derivative is a limit. So we're really just applying the limit properties here. The power rule is going to be your new best friend. This is going to be the most often used rule, I would say. And it's the first one that really simplifies things for us because when we take the derivative of something like x squared or x cubed and we try using the limit process, we have to multiply out that x plus h to whatever power, and that just gets tedious. So the power rule actually becomes real quick and easy. If we have the derivative of x to the n, we take the power and move that out to the front, and then we then have x to the n minus 1. So for example, the derivative of x squared would be a 2, comes out in front, x to the 2 minus 1, so x to the first, so just a 2x. The derivative of x to the 5th would be a 5, x to the 4th. The final rule we'll look at today is the sum or difference rule. Again, this is essentially just a limit rule. If we have the derivative of a function that includes a sum or difference of two functions of x or constants, then we can worry about the derivatives separately. So we would take the derivative of f of x and then add or subtract whatever we get when we evaluate the derivative of g of x. And again, that was a limit property that we had. The limit of f of x plus g of x was the same as the limit of f of x plus the limit of g of x. So we'll do a couple quick examples that use multiple rules at once, and this should all become very simple to you. So let's look at the derivative of x squared minus 3x plus 1. Using the limit process, that would take us a good chunk of time, but now with the rules that we have, we can worry about the derivative of x squared. That is just a 2x. The power comes out to the front, and then we reduce the power by 1. Then we have this minus 3x. So we can consider the minus 3 as a constant. The derivative of x, so if we think about this using the power rule, well, two options. First, you could think about it, well, that's a line, and so the slope at every point is 1. So the derivative of that should be 1. Or, if we use the power rule, we have 1x to the first. So we multiply the front of that by 1, and then we have x to the 0. Right? We would have 1x to the 0, which is just 1. So the derivative of a minus 3x ends up being just a minus 3. And then the derivative of the plus 1, the derivative of a constant, is 0. So the derivative of x squared minus 3x is just 2x minus 3. Lastly, we'll look at when we're asked to find the derivative of a function. So the notation might just be different. So here we're finding f prime of x. So f prime of x in this case is going to be the 1/3 just kind of hangs out in front. To take the derivative of x cubed, we pull a 3 out to the front, and then we'd reduce the power by 1, so we have an x squared. And then the square root, you might be thinking, well, we haven't looked at a rule for square roots. But don't forget that as a power, the square root of x is just x to the 1/2. So we can still apply the power rule. This is going to be a minus 1/2. All right, that power gets pulled out to the front. X to the, now we take 1/2 and subtract 1, and we get a negative 1/2. So 1/3 times 3 is 1, so the first term is just an x squared, minus a 1/2 square root of x, because the negative 1/2 is going to put that in the denominator since it's a negative exponent, and then we have a 1/2 power, which we could rewrite as a square root. So our derivative here is f prime of x is equal to x squared minus 1/2 square root of x.